All right, yeah. So I spend most of my time on the front end repo over here on the right, and that code base has grown by about 75% since I joined Audit Board. It feels bonkers, like considering the number of years Audit Board has been around since before I joined. But the growth isn't my fault, I promise. It's a team effort, and unfortunately, or maybe fortunately, I don't know, I'm still net positive on my impact. Hopefully I can go negative at some point, because that would be really cool. Anyway, if Audit Board is interesting to you, come find me sometime. All right, so reactivity. There are so many reactive packages. There are so many packages in general. This problem extends to all of JavaScript. I'm not sure if this is unique to JavaScript or the problem exists everywhere and is exacerbated by the popularity and size of the JavaScript ecosystem. Maybe it's a sort of lack of willingness for the JavaScript ecosystem or any of its sub-ecosystems to commit to be a batteries-included framework. So we have Glimmer tracking, that one, track built-ins, and some more, and some more. And there's just so many packages, you know? Like, how do you know what does what? Do you need to care? Like, why do we have so many? Seems like an issue, right? And that was all just entirely the packages that the Ember ecosystem is interested in. If I were to include the other ecosystems, we'd be here all day. But before I get into why, let's see what these packages are even doing. So these are the polyfills. Some of these aren't implemented yet and could probably use some dedicated focus from someone so that we can all drop the polyfill and its dependency tree. Or there are maybe a handful of people on Ember source versions that don't natively provide the behavior that the polyfill is polyfilling. In the case of Ember cached decorator polyfill, many folks have been using that after Ember source 4.5, which is when the cached decorator was introduced, just for types, because native types weren't available until Ember source 5.1. These are the community libraries. There are probably more, but this is what I could find. These largely consist of helpful utilities to help your productivity and to implement common patterns seen in web apps. These community libraries wrap data structures, such as the native ones, objects, arrays, maps, etc. Others wrap more complex things, like promises or queues. Some of these libraries that provide reactive abstractions consume the other libraries for even higher level abstractions. 3 of these used the track storage polyfill because the track storage primitives haven't been implemented yet. So if anyone wants to help boost everyone's runtime performance, getting track storage primitives implemented would help a great deal. One of these is a bigger pay-as-you-go package providing many reactive utilities in protest of overly small packages. Disclaimer though, this one's mine. But it has things like reactive implementations of image, functions, fetch, synchronization, keep latest, wait until, etc. I use it in all of my projects for at least one of those utilities, and that's also what you use if you want to migrate from Ember Resources v6 to Ember Resources v7, which I now have a code mod for. These libraries are not v2 add-ons. They may have v2 replacements, or maybe they need help becoming a native package. Most of the community libraries are v2 add-ons, though, and that's very exciting. Nice work, everyone. That's like all what you're doing. Yeah, woo! These are explorations or experiments. These libraries are provided by the framework. And something a little different from what we've been looking at so far is the standardization proposal of signals, which is the combination of years' worth of learning across the JavaScript ecosystem and beyond. And Ember is involved. But what are signals, you might be thinking? They are the reactive primitives that we can build @tract on. Our very own LifeArt has done some experimenting with the proposal in an Ember-like environment, and that has led to some major performance improvements for the particular example implementation provided by those working on the proposal. What's cool about Signals is that it would enable all frameworks, data, and utility libraries to be compatible with each other. And where does most of the business logic of an app live? In data and utilities. What's cool about all of this is that it would all happen transparently to us app devs. We keep shipping features as normal, being productive, and then one day, as we're doing our normal regular maintenance and dependency updates, we're suddenly reactively compatible with the other reactive libraries out there, provided they also build on top of Signals. So Starbeam is a project exploring how we can share concepts beyond reactivity with the world, providing consistent timing within each JS ecosystem for lifetime, providing modifiers, resources, and data derivation patterns we use so that consumers of our abstractions can just write lazy JavaScript. Starbeam is also exploring new ways of rendering and debugging apps. For a little preview, on the left is some sample code from Starbeam's docs, and on the right is the standard Ember code. Both are reactively equivalent, but the important thing to note is that on the right, that is the same code you'd write today. And if you hadn't heard about Starbeam before today, don't worry about it too much. Like with TC39 signals, adoption of any changes into Ember's reactive primitives would happen without you even knowing. It's a project about unlocking more power for us as app devs and making sharing and debugging way easier than it has been for any signals-based environment. But there are a couple of concepts in Starbeam that you can explore with today, though. In Ember resources, a couple of useful things have been implemented on top of public Ember APIs in a way that is code moddable to Starbeam, though with fewer features than Starbeam, as Ember doesn't yet have all of the needed primitives to fully implement what Starbeam is doing. And those two things are cells, pictured on the left. They represent what our tracked decorator would build on top of and are directly analogous to signals themselves. Resources, pictured on the right, are a low-level utility representing an object with lifetime, which is a lot of things within the framework: components, services, routes, controllers, etc. Though it's the resources that have extra useful features in Starbeam that we can't yet use. And for a quick detour, if you happen to already be using Ember resources and are on a version less than 7, maybe version 6, there's now code mod to automate the migration to version 7, even in monorepos, and in some cases it'll migrate you off version 5 as well. If you want to know more, there's a link to more, as well as source code and what is involved in the migration. It's not much. It's basically find and replace. Version 7 is about reducing API area to just what resources are and declaring stability. I don't plan on further changes, basically. All of the utilities within Ember resources have moved out to Reactive Web, and that library has the same support of 328+. Ember resources is just the primitives. As you can see here, version 7 is 770 bytes after Brotley. So if you don't have to update, but if you do, it'd make me feel better. But let's get back to dependencies and stuff. Here's the relationship between all the projects and how they relate to each other in the long term. So Signals is kind of what came out of research from Starbeam, Ember, Angular, Svelte, Vue, Solid, basically everyone with a reactive library is involved in the proposal for making Signals a standard. So likewise, the direction of Signals will influence Starbeam and Ember's internals, abstracted away from app developers, of course. And Starbeam is influencing Ember resources, which is influenced, or maybe rather gathering feedback from Ember about the ergonomics of resources, which are then providing feedback to the Signals proposal around the ergonomics of composing reactive structures with lifetime. But why are there so many reactive packages? We've looked at what they're all doing, but why do they exist? Why so many? And are there too many? Maybe. So one thing is I feel like people may feel like there's kind of a high bar for making something built in. And that's a little true, but let's look at what's involved. You need to submit an RFC, which precisely describes the API you want to add. You need to get people to read it. Then there can be some back and forth. And at the quickest, it may be 2 to 3 weeks between proposal and being accepted for implementation, which for a process that gives the whole community a chance to weigh in on the direction of the framework, That's pretty good, especially compared to dealing with local governments, if you've ever done that. So once the RFC is accepted, it's implementation time. This can be as quick as you want it to be. And then there's documentation to do. However, we often encourage folks to explore an idea in a library. Like if all the public APIs you need are available, it's a good place to start before trying to write an RFC, as the things you discover can and usually do influence what would be written in the RFC. But for me personally, the hardest parts of this process are getting folks to read what I wrote and writing documentation. So when you start an experiment as an independent library, in order for it to be successful, you run into needing to do a lot of the same things you would do for the RFC process. There is, however, this is where a lot of things get stuck. But that's kind of okay because everyone can use the thing and we can let usage and organic growth help determine if the library should be brought into the framework or, more common, being added to the blueprint. And for the framework, the strategy of adding things to the blueprint is a useful tool. It gives us a chance to assess more adoption and see if any accidental anti-patterns or other problems arise from broader adoption. If needed, libraries could be removed from the blueprint. The adding to the blueprint strategy doesn't solve the problem of too many packages, but it does help with guiding you towards recommended things. And working on new features in this way, via a library, does have a huge benefit though. README-based documentation can be a good seed into what may become official documentation for the guides or API docs. But this all leads to the next thing. There are still things to explore with reactivity. This is coming up in TC39 signals, as well as Starbeam, Ember resources, etc. Nearly every Thursday, Ember has an open spec meeting where members of the core team and members of the community can come together and discuss where we want to take the framework, what features we want, and what considerations folks might need to be aware of as they explore implementing those ideas or features. This spec meeting is where we've discussed resources, Starbeam, their ergonomics, as well as some super rough, high-level hypotheticals for signals, pending they get accepted into the JavaScript language. Here are some things being discussed at TC39 that we've talked about during spec meetings. Things are, in a way, holding up the shipping of resources and the overall unification of our low-level framework concepts. These are important ergonomic challenges to overcome, and if you've worked with resources and tried composing them, or in general, even outside of resources, tried composing any reactive objects with some form of lifetime, you've maybe seen this function or value coloring problem mentioned by Dead Claudia here on the right. Let's see what this looks like in practice. I think it's easiest to think about or solve this problem from the user-facing API backwards. So let's say we want a resulting API like this, where we have is pending, is error, error, and a result property. We can define a resource that has matching properties. Now, if we look at the implementation of one of these return getters, is error is here, there's some nuance and some rough edges. For example, notice here that both the evaluation of A and B have a property to identify if they have errors, but they are named different. We are responsible for normalizing that for our consumers. And here, we have to already have the values for A and B's error properties so that A and B are pulled on at the same time so that they evaluate. I think this can probably be looked at another way with is loading. So here we eagerly access the loading properties, just like with the errors. But a common thing developers might want to do is a more natural way of saying this or that by accessing it this way, with one property after another. So because isLoading is typically true initially, each of the used reactive objects are not evaluated until they are accessed. So reactive object B does not start evaluating until reactive object A is finished. And this accidentally creates a waterfall. This isn't a new problem with resources, and when you're working with reactive data in component classes or services, you will run into the same behavior. And in reactive programming across the board, not just Ember resources, Starbeam, or signals. When we want to compose reactive objects with lifetime, and these could be requests, storage accesses, or socket interactions, maybe waiting for a user interaction, any number of things. Somewhere, we have to unify their reactive properties for everything we want to propagate through the reactive layers. Or we pass on that complexity to our users. We have a couple ideas on how we want to solve this, but they required a unified pending management API, as well as experimentation to see if they compose nicely. If you want to know more on this topic and how different ecosystems are approaching it, or how folks are proposing it be dealt with, here are some good resources. On the left is the async thread on the TC39 signal proposal, and on the right is from Ryan Carniato, the author of Solid.js. And that is where Ryan talks about the same problem and the trade-offs made in Solid to solve for some of the previously mentioned ergonomics and composability issues. So popping off the stack, another reason there is so many reactive packages is unfortunate timing. Sometimes other people are doing the same thing you're doing and no one knows. I see this problem most frequently at large companies when different product groups need a similar feature. They each individually implement that feature, and then it's not until much later anyone even discovers that there are two implementations of the same thing, and that they should probably be combined into a single cohesive shareable feature. In open source, this happens as well. For example, just in the reactivity space alone, we have some duplicate and purpose libraries. So here I've ordered them by my preference, and nothing against the folks working on the other libraries. Maintaining libraries is a fair bit of work, and I appreciate anyone who is maintaining anything. Some of these are just old iterations of a newer library, like in the case of tracked built-ins versus tracked maps and sets, and Ember resources versus Ember could get used to this. Of these libraries, two in particular have the biggest case of unfortunate timing. Nearly 1 month apart, these projects were started in June and July of 2021. So I wrote Ember Deep Tracked, and I like to think I keep up with the community, but I had no idea about Ember Tracked Nested. This case is similar, but not quite the same. Ember, a simple tracked helper, started a year before Cell was added to Ember resources, and having a whole library for just one function feels a little goofy to me. It's kind of an alignment of needs, though, as it's nice to be able to create a track state in the template if you need it and you maybe don't want a class, and the cell terminology and behavior is in alignment with Starbeam. The rest of these are a more natural progression of experiments over time. The old stuff should probably be phased out, and perhaps for some of these we can consider how to get them into the framework in a way that makes sense. Though, if you still need to support IE11, you have to use tracked maps and sets instead of tracked built-ins, or at least the current version of tracked built-ins. Old browser compatibility is another reason similar libraries either pop up or stick around for longer than we'd like. Everyone is upgrading at their own pace. Another thing is that people don't know what they don't know. Everyone is generally trying their best and trying to make work easier for themselves. So what do I or you do with this information? What is applicable? For some things, like signals or Starbeam, you'll have to wait. Unless you want to get involved, that's always a fair bit of fun, and I'd like to see that happen. But for now, we can improve our overall patterns and usage of certain libraries over time. There are sort of two ways we can make things better. We combine the good and avoid our problems. And our reactive utilities across the ecosystem are good enough where I think we can combine them. Many are already in the blueprint. And the things we want to avoid are libraries or patterns that we know didn't work out, and we'd like to phase them out of the ecosystem. So an example of what we could do with combining our reactive packages, and as a migration step, these could just be re-exports from their existing locations. It would take some time, and I think the benefits of having a one-stop shop for things that everyone uses in all of their apps would be good. It would give us an in-framework answer to all the reactive questions that come up while working on real apps that make money, rather than being like, use this from this library, use this from this other library. There is a lazy RFC here from me for combining imports. It needs a lot of polish and probably some focus, but that's where some ideas are thrown around. So why do we want to avoid certain libraries? After all, having to change code is work, and isn't it better to not do migrational work if you can instead do work that would lead to making money? For example, and maybe many of you have heard by now that Ember render modifiers should be avoided in new code. It was meant for a transitional period 5 to 6 years ago. So why is it bad, and why do people keep using it? Both Ember TemplateLint and ESLint plugin Ember will tell you not to use render modifiers, but this alone isn't reason enough. The docs for each, which you can visit via the QR codes here, do have some explanation, but let's dive in. When using render modifiers, the element is not needed. If you're clever, and maybe you just want to get around the lint error without really investigating why the lint error exists in the first place, maybe you'll come up with this. This is a local function, technically isn't using render modifiers. It's similar to another add-on out there, render helpers, which uses the same words as render modifiers, but offers helpers instead of modifiers. Equally problematic, though. They are used as a backdoor to an effect. But what's wrong with effects, you might be thinking to yourself. If you've upgraded from Ember Source version 5.9 or higher, it's possible you've run into the backtracking re-render assertion. I like to call that infinite loop protection. Effects, especially via Ember render modifiers, can cause logical errors that have folks fall into this pit of infinite re-renders, or infinite backtracking assertion errors. I think Ryan of Solid.js stated this very nicely. Most developers think about reactivity as an event system. You have some state, you update that state, and things derived from it reevaluate. Ultimately, that change is reflected as a side effect. So it makes absolute sense that folks will reach for these tools. It's natural to think about cause and effect. The article that this is from is really interesting, and Ryan is a really good educational writer. You should definitely check him out if you haven't already. But what's wrong with effects? Effects cause the spooky action at a distance problem. In your apps, you'll be able to observe that derived data is updating, but because you're not explicitly in charge of rendering, the framework is, which I'm super glad for, because if you've used jQuery or done a ton of imperative UI programming, it can be a real headache. But anyway, when you observe that your UI is updating, you have no stack to look for, no place to put a debugger, and logging can only get you so far. You don't know what caused the change. And this is true for all of Ember, Svelte, Vue, React, Angular, all the frameworks that do declarative UI. Yeah. To take another quote from Ryan of Solid.js, when an effect writes to state, you no longer can walk up the graph of dependencies to know what needs to be calculated. The dependency is gone. It isn't just inefficient, it's error-prone. So let's look at some specific examples. Here's a common case of using the didInsert modifier. Around the middle here, didInsert is calling setData initializing a property. This is silly. When rendering the component, and this is a little hand-wavy, but for brevity, we instantiate the class, we render the component, and during render, we keep track of what modifiers are encountered on which elements, and then create those modifiers. We can't run the modifiers any sooner because the elements don't exist yet. Modifiers may change tracked data, which means we have to render again. This is a bit wasteful. And here's proof. On the left is code generated that generated the logs on the right. And at the bottom center here is a QR code where you can run this code in your browser. It uses Ember Source 5.10. As you can see by the number of times things print, we are rendering twice. This will happen to you with render modifiers if you're using older Ember or if you have controlled components. Even if you're migrating away from render modifiers using the quick hack via local function invocation, this double or infinite render may still happen. And speaking of controlled components, let's look at an example. So this is a situation I've found many occurrences of and had to eliminate to progress towards eliminating backtracking re-render assertion, because I want to be on the latest Ember, and you can't have those assertions, you know? Now, this is extremely boiled down, and there's always more indirection involved, making it much harder to spot where the real problem is. So when data updates, updateState is called, which calls the past update function, which sets the original data source, which causes the past data to change, which causes didUpdate to run again, and then we have an infinite rendering problem. It feels goofy, maybe obvious, but I've seen this behavior in real code, and in real code, it's not so obvious. So let's not do this. This is extra work, it's indirection, it's misdirection, it's hard to debug. Instead, set the data you want to begin with. This is much better. But let's look at some less contrived examples now that we know the details of what this process are. In this example on the left, we're setting data on insert that we receive from arguments. On the right, we can just derive it with a getter. In this example, on the left, it's nearly the same as before, except we're using the didUpdate modifier to set data when the argument changes. We still don't want to do this, as we can derive what our local state should be. The code on the right is the same as before. Now, you may be wondering how you would fork state, as the example on the left allows you to set a local state while still receiving external updates from your external data. Without changing the example on the left, you receive external updates anytime your track data changes. But you don't need the element. You don't need to cause unneeded renders. Local copy from tracked toolbox has this use case covered. So coming back to why we want to avoid certain libraries anyway, a lot of development is driven by profit-focused companies. So as software engineers, we need to be sure that all of our efforts have maximum effect, and sometimes if it's net positive, that's good. The outcome of a change must outweigh the cost of doing nothing. For render modifier specifically, I like to think of it as a story of the story as being similar to a company that is going through the startup phase. They're slapping out code left and right, trying to find market fit, pivot to whatever market will pay them. But in doing so, lots of hacks, tech debt, and code that doesn't scale accrues over time. At some point, the debt must be paid, or else developers have greatly reduced efficiency. Maybe by the time a company is stable and found their footing, they have 4 more frameworks in use, and efficiency is lost to too many paradigms, or developers having to learn 4 more frameworks. And those frameworks could even be different eras within the same framework, and render modifiers is from one such prior era. Ideally, there would be some proactive efforts to prevent the getting to a point where developers have greatly reduced efficiency. We've looked at a number of problematic patterns with render modifiers, so depending on how often you have to touch that code could influence when to update to more derivation-based patterns, and it is probably possible that render modifiers may force the private function it uses to become public, so the risk is more mitigated than it is currently. With render modifiers, I think we're probably more in the proactive phase, at least as a community. Your placement in the process at your particular company may differ, but as a community, I'm very hopeful that we're in a good spot with render modifiers and it's not all the... we know where the rough edges are. We know that effects in code can cause debugging, maintainability, and performance problems. We have strategies for removing render modifiers, keeping decent debuggability, maintainability, and performance. That's all I have. Thank you. Again, this is me, and here's where you can find out more about my employer. Thank you.